Next up, we have Jacob, who's going to be covering our capabilities around predictive tool failure.
All right, so MachineMetrics is really doing a lot of special things with workflows and automations in general. And one of the things that we're doing that really no one else in the industry is doing is using our unique access to high frequency data without using additional sensors on machine equipment to detect tool wear to the point where we can predict failures before they occur, saving you significant downtime or even larger expense due to something crashing and breaking a number of other tools or putting the machine out of alignment. And as you can see from this image here, if you're looking at low frequency data, something that's captured more on the level of 1 sample per second, it's very sparse. What you're seeing here is actually data captured at a kilohertz, so 1,000 samples every second. And we're able to see not only the variation, but also the vibration and get other characteristics out of that high frequency data, where we can start to separate the signal from just looking at, for example, maybe we're capturing the load on the spindle. We can actually start to discern what effects within that signal are related to the spindle versus the actual cutting action being taken by the tool against the material. And we can use that analysis to come up with some really impressive solutions for preventing crashes. At one of our customer sites, we have more than 99% accuracy in detecting a failure minutes before, or even 40 minutes in some cases, before the actual failure occurs. This is allowing our customers to save thousands, tens of thousands of dollars per month per asset in some cases. So not even taking into account the amount of downtime that it's preventing. So while this technology isn't technically part of our workflows, it can be tied into them. So you can use this functionality. It's an automation. It doesn't actually fit into what we are in our product called workflows, but it is in a sense a workflow where we detect this anomaly occurring and we send a signal to the machine indicating that it should put itself into a feed hold. And it does. It stops the machine. And you can also use that. You can tie that action into our workflows by sending somebody a notification. So the example would be you're running lights out, nobody's there, the machine stops itself at the point of a failure. That's good, but it would be better if you sent somebody a notification, they came out on site, got the tool replaced and continued on. And then as far as quality goes, you can actually start to see not only that a tool is failing, but even if it has the most finite chip or some imperfection in that tool, it starts to create parts that are out of spec that you could be producing part after part after part that fails. But we can detect that long before you would if you're just running things in a continuous fashion and stop the machine in that scenario too, or just send a notification so that somebody can correct the issue as quickly as possible.